finish up this section, we're going to look at how we can get a sketch of a graph of a function by plotting points. And our strategy is fairly simple. We're just going to take a handful of values, of input values, so our x values, and then find the corresponding y values or output values. So I'll notice, taking a look at this function that we have, y equals 9 minus x squared, the domain is all real numbers, right? There's nothing that we're not allowed to square and then subtract from 9. There's no danger of dividing by 0 or taking a square root of a negative, so there's no restrictions on what I can pick for x. That being said, I want to try to pick a variety, some positive, some negative, and I think I'll go from, say, minus 4 to 4. So for each of these values, I'm just going to find the y value. So we start off with 9 minus negative 4 squared. Now I'm subtracting the square of negative 4. So that's 9 minus 16, which is negative 7. And what this allows us to conclude is that negative 4, negative 7 is a point on the graph of this function. So now we'll continue with the others. 9 minus the square of negative 3. That's 9 minus 9, 0. 9 minus the square of negative 2 is 9 minus 4, or 5. Minus the square of negative 1. That gives us 8. Minus the square of 0 is 9. And now when we plug in the rest of these values, we'll probably notice a little bit of symmetry. 9 minus 1 squared is 8. 9 minus the square of 2 is 5. And so we're seeing the same outputs repeated, and this perhaps isn't too surprising because the only time x appears in the equation of this function right here is when we're squaring it, and when you square a positive number, you get the same thing as if you squared the negative of that number. So 3 squared is equal to negative 3 squared, and so we're not at all surprised down here where we see that if I plug in positive 3, I get the same thing as I did when I plug in negative 3. And when I plug in positive 4, I'll get the same thing that we got when we plugged in negative 4. So now we have a few points here that we can plot. And now I'm just going to start plotting these points. So we've got negative 4, negative 7, negative 3, 0, negative 2, positive 5, negative 1, 8, 0, 9, 1, 8, 2, 5, 3, 0, and 4, negative 7. And once we're done plotting points, we're going to sketch a graph, but we're going to make sure we do so by connecting these dots with a smooth continuous curve, right? So we're plotting a graph, we're not playing connect the dots, we don't want a bunch of straight line segments. We want a smooth continuous curve that goes through all these points. Now I put these arrows on at the end here because certainly we could continue to put in larger and larger values for x, plus 5, plus 6, plus 7, minus 5, minus 6, minus 7, and that would make the value of y, we can see, get smaller and smaller and smaller, or, more negative. And so we're just putting these arrows on to our graph so that we're not trying to say that the graph just ends. The function doesn't just end at -4. It can keep going, and it will keep going according to the pattern that our sketch displays.